So question 3 is all about moles. No, we're not talking about the furry little mammals that like to dig. We're talking about a measure of the amount of a substance in chemistry. Now, when I use the word dozen, I mean 12. When I use the word pair, I mean 2. When I use the word trio, I mean 3. The word mole is just another way of referring to a number, and in this case we're referring to a very large number, because a mole is just when you have this number of particles, 6.02 times 10 to the power of 23. Now that number is named after an Italian scientist called Amedeo Avogadro, and it's called Avogadro's number, sometimes called Avogadro's constant. Now, when you have 1 mole, that's how many particles you have. Okay, and what that means is that we can use this to make our lives a lot easier, because rather than saying we've got this many particles and it's a number like that, an absolutely massive number, it makes the numbers much more manageable in maths. Now you might be thinking, well, where does that number come from? Why have we decided that? Well, you've got to kind of give yourself a theoretical situation where if you take this imaginary mass balance and you put an atom of hydrogen on that mass balance, you won't get much of a reading because one atom of hydrogen doesn't weigh very much, doesn't have a very large mass. So let's put another one on, and another one, and another one, and keep doing that. And you want to keep doing that until the reading on the mass balance is exactly the same as the reading of the relative atomic mass on the periodic table. So when it gets to 1 gram. Now the number of those hydrogen atoms you'll have to add to get up to 1 gram is that number there, 6.02 times 10 to the 23. Consider the same thing for any atom. So you want to aim to get, sorry, for any element, you want to get to the same mass on the balance as the relative atomic mass on the periodic table. You'll need that many particles. Okay, so it's just a way of making our lives easier. Now, fortunately for us, there is a way that we can relate those things together. So the number of moles can be calculated if you take the mass, and that would be in grams, and you divide that number by the relative atomic mass or the relative formula mass, whatever you're looking at. So I'm just going to write, to mean both of those things, the relative mass. Okay, so that's how we find the number of moles. So let's return to this question. So we've got a student and they've got 72 grams of magnesium. So the mass they've got, and I'm going to write this down, is 72 grams. We need to calculate the number of moles, and we're given the relative atomic mass down here. It's 24. So relative atomic mass can be denoted with a capital A and a subscript R. That is equal to 24. So using this equation I've written over here, I can do moles equals mass over relative mass, which is going to be 72 divided by 24. And if we do 72 divided by 24, that gives us an answer of 3 moles. Now, if you do that, that will get you 1 mark, okay, because you've just taken those numbers and divided them by one another. So 3 moles of magnesium if you've got 72 grams. So now we move on to part B. This time we're told that the student has got 3.4 grams of methane, CH4, and we need to calculate the number of moles of methane. So we're doing the same thing, we're calculating moles. So we're using that equation, moles equals mass divided by relative mass. I'm going to denote it MR this time, the relative formula mass of a substance. That's what that symbol means. And let's look at the information we've got in the question. Well, we're told that the mass is 3.4 grams. The relative formula mass of methane, though, we don't have. We have only been given the relative atomic masses. Well, fortunately, thanks to the practice we did in question 2, we know how to do this now. Okay, so let's take our methane, which we're told in the question up here has the formula CH4. That means, therefore, we've got 1 atom of carbon, which has a relative atomic mass of 12. We've got 4 atoms of hydrogen, and they've each got a relative atomic mass, of 1. So we add those two numbers together, and we get an answer of 16. So what that means is, if we've done that calculation correctly, we get a mark. So even if you don't know how to do the next bit, you can get a mark for that. Now we substitute our numbers into this equation. So moles equals mass divided by relative formula mass. So we've got 3.4 divided by 16. And if we do that calculation, we get an answer of 0.2125 moles. So if you've rounded it to 0.21 or to 0.213, that's fine as well, but this is the exact answer, and that would get you your second mark for part B. Now part C, again, we're upping the difficulty level slightly, okay? Because this time, rather than finding the number of moles, we're trying to find the mass. So we're trying to find this number here. So we need to do a bit of rearrangement of this equation in order to calculate that mass of sodium chloride. So in order to do that, you've got two options, and I'll go through both of them. So first of all, you can either substitute the numbers in first and then do your rearrangement. So let's do that first of all. So we're told we've got 0.8 moles of the sodium chloride. And then, are we told the relative formula mass? Oh no, we're not. We're only given the relative atomic masses. So we're going to have to do a bit of maths first to find the relative formula mass. So we've got NaCl. The relative atomic mass of sodium, Na, is 23. The relative atomic mass of chlorine is 35.5. If we add those numbers together, we get 58.5. Now, if you get that answer there, 58.5, then you will get a mark, okay? Because you've done your calculation of the relative formula mass. Now, you divide your mass, which we've said, sorry, you divide that mass by 58.5. We need to rearrange this, so we need this on its own. So in order to do that, we need to move the 58.5 onto the other side of the equation. Because it's currently being divided, we need to do the opposite function, which is to multiply. So that means that 0.8 times 58.5 will give us the mass, and if you do that calculation, you get an answer of 46.8 grams. That would be your second mark if you get that right. Now again, just to do the rearrangement, so if your moles equals the mass over the relative formula mass, you might have spotted that you just need the mass on its own, and you want to move this value here to the other side of the equation. So you can do what we said before, because it was divided, we can multiply it, and that will give us our mass like that. And then you can put the numbers in like we did before and calculate it that way. So that was 3 part C. Finally, for this question, we got 3 part D. And now, rather than finding the moles or the mass, this is an unusual one. We're trying to find the identity of a metal, metal X. Okay. All we know is that we've got 432 grams of it, so I'm going to write that down. And we've got 4 moles of it, so I'm going to write that down as well. So we've got 4 moles. Do we know anything about the relative atomic mass? No, we do not. Okay, but we can deduce it using this equation. Okay, so we need to find this value, and I've written MR, but in this case, really, it would actually be better to write AR. Whoops, apologies. It would be better to write AR because we're finding the atomic mass of an element. Okay. So what do we do then? Well, we need to rearrange this. Well, earlier we found out that relative atomic mass times moles was equal to the mass. We did that in 3 part C. But now I want to find this value, so I need to move moles onto the other side of the equation, which means that I need to do AR, or relative atomic mass, equaling mass divided by the number of moles. So if I do this calculation, which is what I'm going to do now, the mass we're told is 432. The number of moles is 4. So if I do that calculation, I get an answer of 108. So if you've done that, you get a mark. But we need to figure out the identity of the metal. So what we need to do is we actually need to look at the periodic table to find out which element has got a relative atomic mass of 108. So let's go and do that. Here's our periodic table. If you look just below me, just in this group just down here, you'll notice that silver has got a relative atomic mass of 108. So therefore, as a result, our answer is that the metal is silver, okay, because it has a relative atomic mass of 108. If you deduce that, you get the second mark for this question. That was a bit of a longer introduction to moles than I'd hoped, but hopefully that has been useful for you.